Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 466. Page 466, today is our lesson number 23. These are grade-in questions where we have to produce our own answer. There are 10 of them, therefore on a scale of 1 to 10, the problem number 9 and 10 are supposed to be very easy, very simple. Now listen, before I actually get going on the problems for today, yesterday we dealt with the problem on the previous page, problem number 7 on page 465. Problem number 7 on page 465 dealt with the concept of parabola. And I was telling you that if you want to learn more about parabola, these are the videos you can search for. Just type in this, just search for this tag, Geometry for SAT. Geometry for SAT, day 35, 36, day 40 through 47, you will learn about parabola. And similarly, if you want to learn a little bit about circles, you can type in Geometry for SAT, day 37, 38 or 39. In addition to that, what I was trying to tell you is that if you simply search for this tag, fat parabola, and then finally I told you, shifty grandpa, it's supposed to be shifty with an F. I left out the F there. I left out an F yesterday. And I think that changes the things a little bit. So it's supposed to be, it was supposed to say shifty, as in conniving, deceiving, somebody who is underhanded, somebody who is not straightforward. Do you understand? Shifty. Somebody who is of questionable character. I was having fun, you understand? Problem number 9. Problem number 9. When twice a certain number is increased by 5, the result is 14. Alright, so we have some number. When we take twice of that number and increase that by 5, the result is 14. One big freaking deal. Let's solve for x, that's all. Subtract 5 from both sides and we end up with 2x equals to 9, and therefore x equals to 9 over 2. Very good. That's it. Number 2. When I say number 2, I mean number 10. Number 2 as in number 2 in the sequence. That's it, we're done with this one. 9 over 2. Here we are told we have two parallel lines. In the picture above, line L is parallel to M. Y equals 3x. Alright, so here's your x, here's our y, and we are told that y equals 3x. Well, what we have to understand is that if we have a parallel line, and if this thing is x, then this angle will also be x. Again, all you have to do is type in this tag. Just type in parallel lines. Parallel lines. Along with my name, put in Keshwani and then parallel line and type in Geometry for SAT. Something will pop up. There are over 60 videos on geometry. You will find a hell of a lot in there if you're one of those people who is not very good in geometry. Do you understand? And in that video where it talks about parallel line, this is precisely what we talk about. So this angle x, if this is x, then this would have to be x. Therefore, if this is x, this angle is also x. And what do we know about a straight line? A straight line we know makes 180 degrees. Why doesn't a straight line make 180 degrees? Because a straight line represents half a circle. Here's the other half of the circle. If I draw a straight line, the sum of these two angles would of course be 180 because this represents half a circle. And here's the other half of the circle. So anyway, so now we know that 3x plus x, because that's a straight line there, 3x plus x equals 180. 3x plus x equals 180, which is same as saying the 4x equals 180. If 4x equals 180, x would have to equal 180 divided by 4. And how much is 180 divided by 4? How the hell do I know? I know half of 180 is 90 and I know half of 90 is 45. That's good enough. That's good enough. Another way we would have done it without a calculator, is to ask yourself, how many 4s in a 1? 1 has no 4s. So that 1 goes and joins 8 becomes 18. How many 4s in a 18? 18 has 4 4s. 4 4s are 16. The remaining 2 goes and joins this guy becomes 20. How many 4s in a 20? 20 has 5 fours. Well, 45. But that's a roundabout way of doing it. Ask yourself, half of 180, as I said, is 90, and half of 90 is 45. That's how we find a quarter of something. That was number 2. Let's keep on going. Number 3 on the next page. 467. We are given a box and we are given a CD case. Inside dimension of the rectangular box is 4 by 4 by 8. The box is 4 by 4 by 8. What is the maximum number of CDs that one can fit if the dimensions of CD are 4 by 4 by 1/4? Well, if it's 4 by 4, then that part plays no role here. That's just the size of the CD, which is the size of the box here. How many can we stack on top of it? If it's 8 inches deep, and each CD is 1/4 of an inch. Well, if each CD is 1/4 of an inch, in 1 inch we'll have 4. 1, 2, 3, 4. That'll be 1 inch. And therefore, 1 inch has 4 quarters. Therefore, 8 inches is made up of 4 times 8, or 32 quarters. That's how many CDs we can fit, obviously. That's one way of looking at it. Another way, which is a more cumbersome, more academic way, is to simply divide 8 by 1/4. You can divide 8 by 1/4, you're going to have to flip the denominator and it becomes 8 times 4, just as before. 8 inches is made up of 32 quarters because 1 inch is made up of 4 quarters. The quarter is so called because it's 1/4 of 1. And therefore 2 has 8 quarters. 3 has 12 quarters, and so on and so forth. 8 inches will have 32 quarter inch in it, and that is the whatever you want to call it. That's how thick the CD is. This 4 by 4 plays no role. Next one, number 12. We are given an equation here. 3x plus y equals y 6 over 5. The question simply is, what's the value of x over y? X over y. So somehow we have to separate this ratio of x over y. Let's see what we can do. Multiply both sides by y and multiply both sides by 5. So if you multiply both sides by y, this y drops out, and if you multiply both sides by 5, this 5 drops out. So we end up with 6y. 6y equals 5 times this quantity. 5 times 3x plus y. Okay. Just because I switched places, switched the sides in the equation, you shouldn't you shouldn't freak out. You understand? It is no big deal. It's okay to say 4 equals 3 plus 1, and it is equally okay to say 3 plus 1 equals 4. It's not a big deal. You understand? It's okay to switch sides. I prefer to put it this way because this is where we have to do the work, and I need the room to do the work. So now 5 times 3x is going to be 15x, and 5 times y is just 5y, which we are told equals 6y. Subtract 5y from both sides, so that we have x by itself. This is a plus 6, this is a minus 6, minus 5, we have a y here. This drops out, and this becomes 15x. They're looking for the ratio of x over y. Let's divide both sides by y, and we end up with 1 equals 15 times x over y. Now we have to divide both sides by 15. That 15 drops out, and there you go. X over y equals 1 over 15. There is our answer. X over y equals 1 over 15, and that's how you're going to grid in. You're going to actually grid in as 1, and then slash, and then a 1, and then a 5. Don't try to grid this thing into decimal. Do you understand? It'll be a hell. Just keep it as simple as possible. If the answer comes out to be fraction, just leave it as fraction. Don't waste your time with the decimal. Number 13. That's it, we're done. I'll give you a chance to absorb it while I get a chance to absorb my tea. Alright, that was enough absorbing. There's a limit as to how much one is allowed to absorb, you understand? One doesn't wish to be spoiled. Number 13. The table above lists the profit of 3 stores in 2 consecutive years. Alright. What was the average increase in profit in dollars for these 3 stores from year 1 to year 2? Alright. So we don't have to do these 3 stores individually. They're looking for the average increase for all 3 stores. For all 3 stores, the total in year 1 was 21K. Total in year 2 was 26,250. So 26 minus 21 is 5,250. That was the change. This symbol delta represents the change. That was the total change for all 3 stores. And we want the average change for the 3 stores. There are 3 of them, obviously. So we take the total change and divide by 3. So the average change per store is simply your total amount, 5250, divided by 3. First of all, how do we even know that this number is going to be divisible evenly into 3? How do you know if a number is divisible by 3? Well, it's very simple. If the sum of the digits is divisible by 3, the number itself is divisible by 3. 5 plus 2 is 7, 7 plus 5 is 12, and since 12 can be divided by 3, this number is divisible by 3. Let's do it. How many 3's in a 5? 5 has only one 3. 5 has only one 3. The remaining 2 goes and joins this guy, becomes 22. How many 3's in a 22? 22 has 7 3's. The remaining one goes and joins this guy, becomes 15. How many 3's in a 15? 15 has 5 3's. And finally, how many 3's in a 0? 0 has no 3's. 1750 is our answer. 1750 is our answer. Let's do the next one, the last one, number 14. So how do you know? If a number is divisible by 3? If the sum of the digit is divisible by 3, if the sum of the digits is divisible by 3, then the number is divisible by 3. Here's my phone number, 1-800-808-PREP, 1-800-808-PREP, which translates to 7737. Let's see what this number is, shall we? I'm having fun, you understand? Let's see what this number is. This number turns out to be my telephone number. I'm very proud to say is 18,008,087,737. 18,008,087,737. Is that number divisible by 3? Well, again, if the sum of the digits is divisible by 3, the number itself is divisible by 3. Having said that, that's the theory of it. In practice, you don't actually have to add all the digits. I'm going to teach you a trick. You don't actually have to add up all the digits. Here's what you do. We know that 8 plus 7 is 15, so those two play no role. I see another 8 and another 7. 7 plus 8 again is 15. Those are not going to play any role. Oh, I see one more 7 and one more 8. Those are not going to play any role. I see a 3. 3 is not going to play any role. 3 is not going to play any role. What are we left with? Aha, nothing. Nothing else except this guy. What does it tell us? It tells us that my telephone number, not only it is not divisible by 3, but if you did try it, you will have a remainder of 1. You will have a remainder of 1. That was the fun part, you understand? Let's do the next problem. Now we know what real fun is in life. Number 14. We are told that f of x equals absolute value of 3x minus 17. It says, for the function above, what is one possible value of a for which f of a is less than a. If f of a is less than a, that is same as saying this guy 3x minus 7, which is the value of f function. 3x minus 17 represents the value of the function. We are told that this has to be less than x. This has to be less than x. This is a crude way. This is not a proper way, but this is good enough. Watch what happens. Subtract x from both sides and add 17 to both sides. This x drops out and we end up plus 3x and negative 3x. We end up with 2x. This drops out. It's less than 17. Therefore, x is less than 17 over 2. X is less than 17 over 2. I know 16 over 2 is 8. 16 over 2 is 8. There you go. That's one value. 8 would do the job. 8 would do the job. I'm going to show it to you that 8 would in fact do the job, because 8 is less than 17 over 2. I'm going to show you up here. If you put in 8 for x here, we end up with 3 times 8 minus 17. 3 times 8 is 24. 24 minus 17 is 7. And as you can clearly see, in this case, in this scenario, right here in this scenario, f of 8 is less than 7, which is exactly what we were saying. They were saying, what is one value of x for which f of a is less than a? They were asking us, can you give us one value of x such that the value of the function at that value of the x is actually value of the function, in fact, is less than the value of the variable. Well, we found one. 7 would do the job. 17 over 2. Let's try one more, shall we? Let's try 6. See what happens. I'm going to erase this part because we need the room. Let's try 6. F of 6 equals 3 times 6 minus 17. 3 times 6 minus 17, which is 18 minus 17, which of course is 1. And again you can see that f of 6 is less than 1. F of 6 is equal to 1. Oh, sorry, f of 6 is equal to 1. F of 6 is equal to 1, which is less than the value of the x itself. Or I should put it this way, the way we did it here. F of 6 is less than 6, which is same as saying that f of a is less than a. Let's try 3, shall we? Let's try 3. F of 3 would be 3 times 3 minus 17, and 3 times 3 is 9. 9 minus 17 is negative 8, and the absolute value of negative 8 is positive 8. But here f of 3, which happens to be positive 8, is not less than 3. Here f of 3 is not less than 3. It does not work here. But didn't we say that any value less than 17 over 2 would do the job? Because as I told you from the very beginning, it was a crude method. It wasn't a proper method. We'll do the proper method in a second, okay? But as far as the exam was concerned, had you simply realized that anything less than 17 over 2 would do the job, even though it's not proper and correct to say anything less than 17 over 2 because there are limits there. But if you chosen something in the neighborhood of 17 over 2 like we did, like 8 is 16 over 2, which is very close to 17 over 2, that would have been the right answer. 8 does the job, so does 6, so does 7. As long as you don't go too far out in the dangerous neighborhood. Stay within your block where you know everybody. Do you understand? If you go in the wrong neighborhood, you're going to get the I was going to say something bitten out of you, but I won't say it. Do you understand? Let's do the proper way, shall we? Let's do it the proper way. What does it mean when we are told that something equals the absolute value of something? Something equals absolute value of something. For example, if we are told that x equals absolute value of 5, what does it tell you? It tells us that x could be -5 or +5. X could be, or rather, absolute value of x. If we are told that absolute value of x equals 5, what does it tell us? It tells us x could be -5 because absolute value of -5 equals 5 and absolute value of +5 equals 5. X could be either. So if somebody tells you the absolute value of something is this, it could be either. So that same exact thing is going on here. Same exact thing is going on here. This thing here, in reality, could be -1 times 3x minus 17, or it could be simply 3x minus 17. In other words, this quantity in the absolute sign could actually be a positive quantity, in which case the absolute sign will play no role, or this quantity in the absolute sign is a negative quantity, which is why they're putting the absolute sign to tell you to ignore the negative sign. Do you understand? It could be either. Let's find out. If this is the case, then we are told that -1 times 3x, let's actually do it, let's open it out. We are told that -1 times 3x will be -3x, and -1 times -17 will be +17, and we are told that this has to be less than x, because we are told that f of x has to be less than x. Or they put it as, I think they call it f of a, same thing. Same thing here. F of a has to be less than a. So here, 3x minus 17 has to be less than x. Solve for x here, we end up with 2x is less than 17, same as before, and x is less than 17 over 2. This is the part that we did earlier in the beginning of the question, which was good enough for the exam. Doing half the work for this exam, for this question, would have been good enough as long as you stay within the, stay very close to the neighborhood. Here's the second half. Bring the x to this side, you end up with 4x is less than -17. Now when you multiply both sides by negative value, the direction of the inequality has to change. The direction of the inequality has to change if you're going to multiply both sides by a negative number. And I'm going to show you very quickly why. Would you agree that 3 is less than 4? Of course 3 is less than 4. Why wouldn't you agree? Well, what if you were to multiply both sides by 2? Would you still agree that 2 times 3 is less than 4 times 2? Of course! But what if instead of multiplying it by 2, if you had multiplied by -2? Now, -2 times 3 is -6, and -4 times -2 is -8. -6 is no longer less than -8, it is more than that. -6 is more than -8. So when you multiply both sides of the inequality by a negative number, the direction of the inequality needs to be changed. Again, if you're looking for some more example of this thing, all you have to do is put in my tag, my name, Kashwani, and put in inequality and see what pops up. It doesn't hurt to try. Something must be there. Do you understand? Something has to be there, I'm sure, fairly certain, because I have over 1400 videos of all different subjects of math. Something has to be there. Let's multiply both sides by -1. So this -1 and negative becomes positive, which was the whole point, and this will become greater than 17. And therefore x is greater than 17 over 4. And there is your complete answer. The complete answer is that x, whatever it is, has to be greater than 17 over 4, has to be greater than 17 over 4, but less than 17 over 2. Which is why when we tried 3, it did not work. Because it has to be 3, it has to be more than 17 over 4. It has to be more than 17 over 4. What would 3 be then? I don't remember what we tried before. We tried something and it did not work. I'm not going to go back in there and bother with it. But anyway, that's the real range. That's the proper answer. 3 would have been what? 3 would have been 12, you see? 12 divided by 4 is 3. No, that's why it did not work. 3, as you saw in the beginning of the video, it did not work. In the case of 3, f of x was not less than x because it was 3. 3 will not work because 3 is 12 over 4. It has to be something more than 17 over 4 and less than 17 over 2. 17 over 2, for example, if you try 9, it will also not work. This is the range. This is the complete answer. I will see you tomorrow. This was a nasty one, and the next page coming up there, I have good news. It is nastier. Okay? Which is why I divide them into two parts, into 2 days. I'm going to do the first column of the next page in 1 day, and then other two in the following day. Because out of the entire exam, of all the math questions that you see on the SAT, the following page, page number 468, is the nastiest of all. The last 4 grid-in are pretty bad. I'll see you tomorrow, okay? Bye now.